Well, what we're going to do today is starting to go over or learn about some of the elements on the periodic table a little more in detail. Some of the elements are known for very specific things, even in popular culture. Like we watched that video at the beginning of the year, the Poisoner's Handbook, and what is arsenic known for? Hint, it was called the Poisoner's Handbook. Poison. Arsenic is known for being a poison. There's a play called Arsenic and Old Lace. If you read mystery novels, arsenic is one of the weapons of choice if you're going to poison somebody. So some of the elements are known for certain things, even in our popular culture. Some of them are things that you should probably know too. So we're going to pick not all of the elements, but a smattering of elements and learn some very specific things about them. We're also going to do this tomorrow when you do your poster presentations, and then on Thursday, because most likely this set of notes will take 2 days. One of the things that I usually do to spice up this set of notes, because it is a little bit long, is I pull as many of these elements as I have, and I'll pass them around and let you look at them so you can see them up close, and we'll have to make sure we get all of them back. But let's learn a little bit about some of the elements. We're going to start with group 1. What is a group? Is it horizontal or vertical? Vertical. Where is group 1? On the left. So this is the very first group, and it starts with hydrogen and then all the ones underneath it. We're going to leave hydrogen for later because hydrogen is a little bit different than the rest of the group members, although that is where it's organized on the periodic table. But we're going to set hydrogen aside and come back to it later. And we'll actually start that group with lithium. The name of this group we should already know is called the Alkali Metals. We should also already know that its electron configuration ends in S1. We talked about as a group how these elements are not found in nature as pure elements. You cannot go outside and dig up a chunk of sodium. When you find them in nature, they are always bonded with something else. They're always in a compound. And we talked about how these are the most reactive of the metals. Do you remember what they react violently with? Water, which would probably explain why I don't have any of these out for you to look at today. We will do a demonstration with lithium and sodium in a week and a half, 10 days. So you will get to see it, but I don't have any of these out for you to look at today. And they are also some of the softest metals, so you can cut these with a knife. And you will get to see that too in a week or so. Elements in this group include lithium, sodium, potassium, rubidium, cesium, and francium. And they tend to get more reactive as you move down the column. So lithium would be the least reactive of those 6. Francium would be the most reactive of the 6. And that's something that we'll talk about with our second half of periodic table stuff. Things we should know about specific elements in this group. Sodium. You should remember from the flame test lab, this was the one that was bright pumpkin orange when you looked at it. And it is used as the main ingredient in those orange glow street lamps. So sodium vapor, or sodium gas, is what they put inside the bulb on those orangey glow street lights. Bananas are high in potassium. Most people know that, just kind of common knowledge. And I think we've got one more on here. What is lithium used for? Batteries. Lithium is used in batteries. Lithium is also used as a medication for some mental illnesses. Typically, yeah. There are a lot of metals that find their way into medications, which you wouldn't necessarily expect. Those would be called trace elements, that your body has to have certain amounts of them in order to function properly. Group 2. Do you remember what Group 2 is called? Close to Group 1. Group 1 is the alkali metals. Group 2 is called the alkaline earth metals. We should know that their electron configuration ends in S2. Some general group properties. We should also know that they are not found in nature as pure elements. This is the group that's got calcium, magnesium, strontium. You can't go outside and dig up a chunk of calcium. It's always bonded with something else. It's a compound. These are the second most reactive and the second softest metals. And I do have some of these for you to look at. What you see in the picture there, and then what I have in this first little jar is calcium. It doesn't really look like a metal. It kind of looks like white and powdery. It does react with the air to make calcium oxide, I believe. Elements in this group include beryllium, magnesium, calcium, strontium, barium, and radium. We learned about radium in the Poisoner's Handbook too. Do you remember what it was for? It's the one that glows in the dark.
Is it like the watches?
Yeah, girls used to paint the dials of watches with radium because it would glow in the dark. And then what else did they paint? Their fingernails, their teeth, anything, because they didn't realize that it was radioactive and it was going to be harmful to their bodies. They thought it was good for them. That was the propaganda at the time. Things we should know, specific elements from this group. Magnesium, the one that is getting passed around in the center right now, burns very brightly. And so it is used in flares. You think about road flares. You might have them in an emergency kit. Magnesium is one of the things that's used in those. Magnesium burns with a bright white flame. If we have a couple minutes at the end of class, I'll get some out and we will show you that. Calcium, of course, you would expect, needed for strong bones and teeth. Strontium is one that you saw in your flame test lab. It burns with a red flame. This was the one that people tend to describe it as like a fire engine red. It's not like magenta or a cherry red. It's more of a fire engine or a true red. Strontium is often used in fireworks because of that. Every different color that you see in fireworks is coming from a different element. Most of those are metals. And barium is another one that's radioactive. And barium is one of the things that they use to outline your internal organs for x-rays. If you're going to go in and get like an MRI or an x-ray done for something, they will make you drink like this milkshake, slurry kind of stuff. I've never had to do it. I've been told it tastes terrible. Have you done it, John? And Sam's done it too? Is it pretty awful?
It's not bad.
No, it's not bad?
I had it when I was
Oh, so you might not remember as well, maybe?
little.
Chocolate. Maybe they have better flavors now. I was always told it tasted awful. But then there would be just trace amounts of barium in your system, which they'd be able to see on x-rays. So that would be able to make your intestines and other portions of your digestive tract show up on an x-ray, which normally they wouldn't. Yeah.
The weirdest part about it was that if they had the X-ray pulled up so you can see the liquid.
Oh, you can see it going down? That's crazy. We're going to skip the transition metals for now, and we will come back to them. We're going to jump over to group 13. Group 13 would be the one that starts with boron, and it should be the next one on your page. But remember, remember the transition metals are groups 3 through 12. We're going to skip those for a little bit and come back to them. Group 13 is called the boron family. I promise, despite its name, there are a couple of interesting elements in this family. Here is a picture of boron, by the way. I actually don't have this one to show you, but boron is a metalloid, so it shares properties of both metals and or nonmetals. The electron configuration for this group ends in P1. Elements in this group that we should be aware of include boron, aluminum, gallium, indium, and thallium. Please note that is TL, not TI. I have one of the elements of this group. Has everybody had a chance to see calcium? Okay. I have one of the elements in this group to pass around. Can you guess which one it is? Aluminum. I have it in a slightly different form than what you're used to seeing, though. So we'll pass that around. You can take a look at it. Aluminum is never found pure in nature, by the way. It is, I think, the third most abundant element in the Earth's crust, but it's still never found pure. It's always found bounded to something else. So all the things that we make out of aluminum, we have to mine for the minerals that aluminum is in, and then refine those minerals so we can get the pure aluminum out. Things we should know for this group. Oh, the most abundant metal, I'm sorry. The most abundant metal, I think it's maybe the third most abundant element. Have to check by your science book. Do you remember from Earth Science last year? No? Aluminum is used for an awful lot of things these days, from aluminum cans to lightweight parts of airplanes and cars. Aluminum foil, of course. Probably everybody's got that in their kitchen at home. Here's another one that's kind of interesting. Gallium is a metal that has a melting point somewhere between room temperature and the temperature of your body. So if you put gallium in your hand, it will melt in your hand. But unfortunately, I don't have any of this to show you because it also is carcinogenic. What's that mean? Carcinogenic means that it causes cancer, or it's suspected of causing cancer. So gallium is not something that I'm allowed to have in the closet, but it would be pretty cool if we could hold a piece of metal in your hand and watch it melt, just like an ice cube. Thallium is one of the things we learned about in the Poisoner's Handbook. It was one of the toxins that was formerly used as an insecticide. Group 14. It is called the carbon family. We should know that group 14's electron configuration ends in P2. Elements in this group include carbon, silicon, germanium, tin, and lead. I actually have quite a few of these to show you. The only one I don't have is germanium. I think that one may be labeled carcinogenic as well. Things we should know from this group. We talked about how silicon is a semi-metal, so that makes it a semiconductor, and it's used for computer chips. It's actually pretty shiny when you look at it in its pure state, so we'll send that one around. Lead. Most people know that lead is toxic. It's something that they check for in the water on a regular basis. It's something that you're not supposed to have in paint and gasoline. If you live in an old house and you have a small child and you take that child to the doctor for vaccines or whatever, they actually ask you what age your house is to check for lead screening so that they're not eating paint chips. Lead paint chips are supposedly slightly sweet, and so that's why little Lead, in its pure form, is actually really soft, which is kind of neat. Most metals are not this soft. You can bend it. If you bend it too much, it's going to break. So when we pass it around, don't sit there and bend it back and forth for 5 minutes. Even though everybody believes their pencils are filled with lead, what are they actually filled with? Graphite. I have that for you to look at too. But you can make this right on a piece of paper. So if you'd like to test that on your notes, it will leave marks on your paper. And one of the things that you think about with lead is the toxicity. That's the toxicity over time. So lead is poisonous if you are constantly exposed to it or constantly ingesting it. Just having a piece of it and passing it around one time, it's not going to be toxic. But one of the things that it does cause or interfere with is your brain, your mental capacity. So there is somewhat of a historical legend that the Roman Empire built all their water pipes with lead, and that over time the lead would leach into the water. They would drink the water, and Roman emperors are famous for being crazy. Ask Mr. Stinson, he'll tell you. Roman emperors are famous for being crazy, like Caesar and Nero. And so the historical legend goes that lead may have contributed to the fall of the Roman Empire because all the people were ingesting lead constantly from their pipes, supposedly. Yes, ma'am?
Didn't lead paint cause a lot of people to go crazy too? Like
Yeah,
houses?
over time, if you eat enough of it, certainly. Carbon. It's kind of a neat element. Carbon has allotropes. An allotrope is a different form of that same element. Carbon comes in 3 forms, naturally. One of them, Casey did for her Christmas project. Coal. Carbon comes as coal. Did you look at coal last year in earth science? Sedimentary rock. And a metamorphic rock too, actually. So we'll pass that around. You can take a look at that. Carbon also comes as the stuff in your pencils, which you told me was graphite. Now, I could pass around the pencil lead, but that wouldn't be very exciting. So I have instead powdered graphite. What is powdered graphite used for? Boy Scouts? Pinewood Derby cars? No? If you are in agriculture, planting season, what do you use those for? Graphite is very slippery. Graphite powder is very slippery when you rub it between your fingers. So if you ever made a Pinewood Derby car, which is just a little wooden car that you send down a hill on a track, it's used to put on the axles, and kind of like it greases your axles. In agriculture, I know my husband uses graphite every spring to more or less grease the parts of the planter so that I don't even know how it works. I think there's a wheel inside with fingers that it picks up the seeds and then drops them. Anyone confirm that? No? Okay, well, as far as my understanding goes, that's how that works, that they have to have graphite in there to kind of lubricate the parts. It will turn your fingers pretty gray, though, if you open the bag, so be aware of that. What's the third form of carbon? Anybody know? It doesn't look anything like the other two. This one. Diamond. Diamond is the third form or the third allotrope of carbon. Sorry, I'm not passing around my wedding ring for you guys to look at. It's the only diamond I own.